Let's finish up our study of section 11.4. Goal number 2, we're looking at how to find limits of a sequence. So limits of a sequence have many of the same properties as limits of functions. For instance, let's consider the sequence whose nth term is given by this formula. And as you recall from our study on sequences, to find the terms of a sequence given the formula, we begin by plugging in our integer values for n. N is equal to 1, would give us 1/2. N is equal to 2, 1/4, 1/8, 1/16, 1/32. So let's look at our limit as n approaches positive infinity. So if we continued to plug in integer values for n, what would this limit get closer and closer to? Well, it's easier to read that if we have decimal values rather than fractions. So let's convert these fractions to decimals. So we'll come way over here, and we know that we would have 0.5, so that's 1/2, and then 0.25 is 1/4, 0.125 is 1/8, 0.0625 is 1/16, 0.03125 is 1/32. And notice we could keep going and going and going. So what I want you to see is that as n increases without bound, that means approaches positive infinity, the terms in this specific sequence are getting closer and closer to. Maybe you're not sure what they're getting closer to, so if you're not sure, we could plug in the next value for n, which would be 6, and that would give us 1/64th. And 1/64th is 0.0156. Can you guess what the limit is now? If you're not sure, the next term is 1 divided by 128, or 0.0078. And you could keep going, but hopefully by now you've recognized that as n increases without bound, this sequence is getting closer and closer to 0. So we would use this word to say that the sequence is said to converge to 0. So as n, or your x value, approaches positive infinity, your limit is getting closer and closer to 0, or we can say that the sequence is converging to 0. So using limit notation, here's what the function would look like. So the limit is n approaches positive infinity, for 1 divided by 2 to the n power is equal to 0. So we had our discussion and then looking at the limit notation. So a little terminology: a sequence is said to be convergent if it approaches some unique number. 0 would be a unique number. A sequence that does not converge is said to diverge. For example, if your y values hopped back and forth from 1 to -1, 1 to -1, 1 to -1, this series would be considered to be divergent, or it diverges because it does not approach a unique number. And here is the equation for that type of sequence. All right, I want you to do a little bit of analysis. I want you to pause the screencast, and I want you to find the first 5 terms of each sequence, and then state what you think the limit is if it exists. If it does not exist, then explain why. Assume that n begins with 1, so you're going to find A1 through A5. If you feel like the first 5 terms are not enough for you to determine the limit, then find the 6th, the 7th, the 8th. Find enough until you can determine whether the limit converges to a unique number and list that number, or whether it diverges.